Okay, one of the big parts of solution concentration is being able to calculate concentration in a number of different ways. We're going to talk about molarity, which you know the moles of solute over the liters of solution. The mass percent, which is the grams of the solute divided by the grams of the solution. Remember, the solution is composed of two parts, the solute plus the solvent. Then we're also going to talk about the mole fraction, and you can talk about mole fraction two ways. For today, we're going to talk about the mole fraction of the solute. That would mean that we're talking about the moles of the solute over the moles of the solute plus the moles of the solvent. Remember, a fraction is part of the whole, and that hasn't changed since third grade. You can see that there it is right there. So let's tackle this first problem. A solution is prepared by mixing 1 gram of ethanol and 100 grams of water to give a final volume of 101 milliliters. Calculate the molarity and the mass percent and the mole fraction. Well, the first thing I am going to do in this problem is I'm going to find the number of moles of the ethanol of C2H5OH equal to 1 gram, and I will multiply that by its molar mass. 1 mole of ethanol has a molar mass of 46 grams, so 1 gram of ethanol has 0.0217 moles. There we have it. And I need to know the number of moles of water in 100 grams of water. And each mole of water has a molar mass of 18 grams. And that gives me 5.56 moles of water. So I think we are ready to go with our first calculation, and that would be molarity. Molarity is the moles of the solute. In this case, that would be the ethanol, divided by the volume in liters of solution. So the moles of the solute we have just calculated is 0.0217 moles. And the total volume of the ethanol and the water is 0.101 liter. It's 101 milliliters. Divide that by 1,000 to get liters, and that means that our molarity is 2.15 molar. Our mass percent is calculated by taking the mass of the solute and dividing it by the mass of the solution, and that would be U, adding together the solvent and the solute masses, and then we're going to multiply that by 100%. The mass of our solute is 1 gram. That was given to us in the problem, and we know we have 1 gram of solute plus 100 grams of solvent. Multiply that by 100%. Some parentheses around here to keep our math nice and straight. And that gives us a mass percent of 0.990%. And now we need to find the mole fraction. Mole fraction of the solute is represented by the Greek letter chi, and we subscript the solute, and that is the moles of the solute, 0.0217, divided by the moles of the solute plus the moles of the solvent. And we see there is far more solvent than there is solute, so we would expect the fraction, the mole fraction, a unitless number, to be 0.00389, which It certainly is very small. Okay, going to our next page and our next problem. All right, the electrolyte in automobile lead storage batteries is a 3.75 molar solution of sulfuric acid that has a density of 1.230 grams per milliliter. Calculate the mass percent. Well, we recall that the mass percent, or the percent by mass, would be the mass of the solute, which in this case would be H2SO4, over the mass of the solution, which would be the mass of the H2SO4, plus the mass of its solute, which is, or its solvent, I'm sorry, which would be the mass of water, times 100%. We don't have either one of those things, but we can find them easily. Let's recall the definition of molarity. Molarity is the number of moles of the solute, H2SO4, in 1 liter of solution. So if we know that it's 3.75 molar, how many moles is that? When there is, by definition, 1 liter, well, that would be 3.75 moles of H2SO4. All right. We can figure out the number of grams of H2SO4 equal to 3.75 moles. We need that to find the mass right here. Put it in that our target equation. 1 mole of sulfuric acid has a molar mass of 98 grams. So the mass of our solute is 367.5 grams. All right, that gives us part of what we need to know. Now we need to know what the mass of the solution is. And they've given us the density of the solution. The density of the solution would be the grams of the solution, which would be very helpful for us to finish this problem, divided by the volume of this solution. Clearly, we can see that we have the density. We need the grams. What are we going to use for the volume? 1 liter. We are making a supposition. If we have 3.75 moles, that would be in 1 liter of solution. So 1.230 grams is, grams per milliliter. The density is equal to how many grams if we have 1,000 milliliters. Where did the 1,000 come from? 1 liter is equal to 1,000 milliliters. So the grams, or the mass of our solution is 1,230 grams. Now we can finally put some numbers into our equation. The percent by mass is equal to 367.5 grams, the mass of our H2SO4, over 1,230 grams, our total mass of the solution, mass of H2SO4 plus the mass of the water. Multiply that by 100%, and that is 29.9%.